On September 7, 1941, the Prime Minister of Great Britain, Winston Churchill, signed an order demanding an increase in the production of bombers by the end of 1942 by an additional 3,500 aircraft on top of those already ordered. Such a high level of production could be achieved only in one way, by concentrating all efforts on models already in service and postponing the development of new, potentially better aircraft. Situations like this often occurred in the aviation industry during the Second World War. This order had the greatest impact on two aircraft produced by Vickers Armstrongs, the Wellington and the Warwick. The planned transfer of two factories from producing the former to the latter was postponed to increase the number of Wellingtons. This delay in turn slowed down the refinement of the Warwick and destroyed all hopes of using it in the future as a bomber. By the time it was finally ready, it had already been displaced by a new generation of medium and heavy aircraft, and it became unnecessary. But even in 1941, the Air Ministry regarded the new Vickers bomber with skepticism. Its production was planned only because its geodetic construction shared much with the well-mastered Wellington, and Vickers would have lost much time in switching to a more advanced stressed skin design. The story of the Warwick begins in July 1934, when Vickers became one of 4 companies invited to take part in a competition to create a heavy day and night bomber. This was a supplement to an earlier specification under which 2 aircraft were already being built, the Hampton by Handley Page and the Wellington by Vickers. In response to the new specification, Armstrong Whitworth produced the Whitley. But in March 1935, the Air Ministry began preparing a new, more complex requirement for an aircraft intended to be the successor of the previous. The new specification, issued on May 8, 1935, described a twin-engine aircraft with a maximum speed of 230 miles per hour, capable of carrying 4,000 pounds of bombs to a distance of 1,000 miles, or 3,000 pounds to 10,500 miles, or 2,000 pounds to 2,000 miles at a cruising speed of 150 miles per hour. As before, the Vickers Design Office under Reginald Pearson proposed an enlarged version of the Wellington. Bristol Hercules engines were intended, but in all other respects the new project was very similar to the original Wellington. The only difference was in size. The wingspan was increased by 11.5 feet by extending the outer panels, and the fuselage was lengthened by 9 feet by inserting a straight section in the middle, as required by the specification. Gun turrets, designed by Vickers as on the Wellington, were placed in the nose, tail, and fuselage sides, 4 guns in total. 8 months before the first flight of the Wellington prototype on October 7, 1935, Vickers received a contract to build a prototype designated Type 284. It was intended for comparative trials with the Handley Page and Armstrong Whitworth aircraft. According to the specification, the full weight of the Type 284 was to be 30,500 pounds and overloaded 36,000 pounds. At normal weight, it could deliver 4,500 pounds of bombs to a distance of 140 miles at a cruising speed of 232 miles per hour at an altitude of 15,000 feet. The calculated maximum speed was 248 miles per hour at 15,600 feet. In the overloaded variant, the maximum bomb load increased to 7,500 pounds and the range was 840 miles. At a distance of 2,400 miles, 5,150 pounds of bombs could be delivered. When the design of the Type 284 took shape, detailed work on the production Wellington was already underway, and great effort was made to unify the 2 aircraft. Although the Warwick, as the new Vickers bomber was named, was seen in the future as a replacement for the Wellington, at the beginning of its development it was considered a complementary. Both the Air Ministry and Vickers gave priority to the Wellington. Work on the new specification in 1936 proceeded very slowly. Its future was overshadowed by the appearance of twin-engine medium bomber projects under a later requirement. Although initially defined as heavy, that term was soon reserved for much larger aircraft. Handley Page reworked its project under the new demands. As a twin-engine aircraft, it competed with Avro's Manchester, but it was then redesigned into a 4-engine machine even before a prototype was built. Vickers, by contrast, continued developing its project almost in its original form, although much attention was devoted to power plants since the weight growth rendered the Hercules engines unsuitable for them. On July 6, 1937, a second prototype of the Vickers bomber was ordered, identical to the Type 284 but with new promising Rolls-Royce Vulture engines. After that, the Air Ministry suddenly decided that the Vulture should also replace the Hercules on the first prototype by WWII, while on the second prototype it required interchangeable installations for both the Vulture and the Napier Sabre engines. The redesign of the second aircraft was carried out under the designation Type 400. In December 1937, work began on yet another alternative engine, the Bristol Centaurus, as Type 401. At about the same time, all future prospects of the new Vickers bomber began to be reconsidered, since the appearance of aircraft under an even newer specification was expected soon. The alternative engines hardly affected the range with different bomb loads, but they promised an increase in speed to 332 miles per hour at 17,600 feet with Vultures and 340 miles per hour with Sabres. Meanwhile, the Wellington experience led to the use on the new bomber of Fraser-Nash turrets with twin machine guns in the nose, tail, and dorsal positions. A similar ventral turret was also planned. By the end of 1938, the first two prototypes were close to completion, but the engine situation remained uncertain. A pair of Vultures had been obtained for the first prototype, but this engine was intended for the production Manchesters by Avro, and the possibility of acquiring it in large numbers was severely limited. It was unlikely to be allocated for Vickers bombers. Production of the Sabres was behind schedule, so the second prototype was fitted with Centaurus engines. The Air Ministry decided that the only reason to launch the Warwick into production could be its geodetic construction. In February 1939, it was decided not to start series production, but already in June, the preparation of tools and equipment resumed. They were only waiting for flight. These began on August 13, 1939, when Mutt Summers made a short flight with one observer on board. The maximum weight had already risen to 42,200 pounds, but even at a takeoff weight of 30,000 pounds, as in the first flight, performance was poor, handling was bad, and the aircraft could hardly fly on one engine. This was a discouraging start for the new bomber. Somewhat better results were obtained with the second prototype, which Summers flew on April 5, 1940. The Centaurus engines proved more reliable than the Vultures, but neither of these engines was available in sufficient quantity for use on the Vickers aircraft. The Vulture, installed on Avro's Manchester, soon fell into disfavor and was withdrawn from production, while the Centaurus was simply not yet being mass-produced. The Sabre, also considered as an alternative, was urgently needed for Hawker's Typhoon fighters. In July 1940, engineers began studying the possibility of installing powerful American Pratt & Whitney engines on the new aircraft. These engines had the nickname Double Wasp. At the end of the month, the Air Ministry transferred a pair of such engines to Vickers for trial installation on the second prototype. According to calculations, with such engines, the new aircraft could carry twice as many bombs as the earlier Wellington, while retaining all other characteristics. Despite some handling problems, which required changes to the tail section, a way was found to redirect part of Vickers's production capacity from the Wellington to the new machine. This also took into account the opinion that the Vickers factories at Weybridge and Blackpool would be difficult to switch to aircraft of a different design. On January 3, 1941, Vickers finally received an order for a series of aircraft under the name Warwick. The order included 150 Warwick the Word aircraft with American Double Wasp engines and 100 Warwick II aircraft with British Centaurus engines. This success inspired the design office to develop the Warwick III, with a pressurized cabin like that of the Wellington WWII and VI, and a power plant of either 2 Centaurus engines or 4 Merlin engines. The latter option interested the Air Ministry as a high-speed, high-altitude bomber, and a technical specification was prepared for it, becoming the first step toward the creation of the production of the Warwick, which began in the first months of 1941, was already suspended by September. The first production example entered flight trials only in April 1942. This aircraft, which arrived at the Boscombe Down Test Center on July 3rd, had a takeoff weight of up to 36,900 pounds. On August 28th, it crashed and burned after the fabric covering tore off the wing. The second aircraft fared little better. It was used for studies of different methods of improving control surface efficiency and for evaluating controllability in single-engine flight. The aircraft crashed when an engine caught fire during takeoff from the Farnborough airfield. Redesigns of the tail unit and corresponding tests were carried out on 3 more production Warwick B Mki aircraft. However, a management decision approved on January 21, 1943, to use the Warwick as a transport and maritime patrol and rescue aircraft completely buried the hopes of employing it as a bomber. Of the 250 aircraft of the first order, only 17 appeared in the original bomber form. Of these 17, one was in fact the only BMK-2 with Centaurus 4 engines. It took to the air in July 1943 and was used by Bristol as a flying testbed for engines. Later, it was fitted with a Centaurus 8 engine. It served until October 1945. The aircraft could take off at a weight of up to 47,500 pounds and showed a speed of 290 miles per hour at an altitude of 20,000 feet. In total, 219 out of 250 aircraft from the first order actually entered service with the Royal Air Force, where they were used in the Air Sea Rescue Service. Another 14 were operated as transport aircraft by BOAC. The official decision to adapt the Warwick for carrying troops, passengers, or cargo was made in early 1943 and resulted in the final transport variant for the RAF. However, BOAC anticipated these developments by about a year. An aircraft was needed for the trans-African route from the river port of Bathurst in Gambia, where flying boats from Great Britain arrived to Cairo. In 1942, Vickers received an order from BOAC for 14 aircraft. The basis for the BOAC machines was the BMKI with the same American double WASP engines of 850 horsepower each. The nose, dorsal, rear, and ventral turrets were removed, and fairings were installed in the nose and tail sections of the fuselage. Windows were added to the cabin, additional fuel tanks, flame dampers for night flights, and a reinforced cargo floor were designed. The first aircraft built to this specification took to the air on February 5, with a takeoff weight of 42,000 pounds. The transport aircraft carried a payload of 9,600 pounds. They were used by BOAC mainly for transporting mail and cargo on routes in the Middle East and Africa in 1943. These aircraft were converted from BMKY and carried civilian designations. In 1944, BOAC returned them to the RAF, and they were given back their original military serial numbers. They served with 525 Squadron and later with 167 Squadron of Transport Command, where they were designated Warwick CMKE. While work was being carried out on the aircraft for BOAC, the Vickers Design Office addressed RAF requirements for a cargo passenger aircraft. The requirements for such a machine included transporting 6,700 pounds of cargo over 2,000 miles at a cruising altitude of about 15,000 feet. Load options included 26 soldiers with full equipment, 20 paratroopers, 8 to 10 VIP passengers, 6 stretchers with room for 2 medical attendants, and various cargo, including aircraft engines. The machine also had to be capable of towing gliders and carry a crew of 4. Once again, the BMKI served as the basis. Officially, the transport was designated Warwick CMK III. It was powered by double WASP engines like the original bomber, although a similar CMK-4 variant with Centaurus 4 engines was planned. The CMK-3 was fitted with engines rated at 1,150 horsepower. Similar to the BOAC variant, the transport CMK-3 had nose and tail fairings for stowing light cargo, but in some aspects it differed from the first conversions. The opening for the ventral turret was repurposed as a parachutist jump hatch, and a door was added on the starboard side for loading stretchers. A large, protruding rectangular container ran the entire length of the bomb bay, with the bomb bay doors removed. Instead of cargo, this container could hold 4 fuel tanks of 150 gallons each, probably to increase range. However, a tanker version was also designed with 100 gallons of fuel in cylindrical fuselage. Vickers received an order for 100 Warwick CMK III. At the same time, additional orders were placed for rescue and reconnaissance variants of the aircraft. The first CMK III was completed in the spring of 1944 and was tested at Boscombe Down from April to October 1944. There it was evaluated in various ways, including flights without the ventral container at weights up to 45,000 pounds. Squadron 525, based at Lyneham, received 12 CMK 3rd aircraft in July 1944. Plans to send the new transports to the Far East were abandoned due to the cracking of the fabric covering under high humidity and temperature. Restricted to operations only in Great Britain and the Middle East, and suffering from engine unreliability that led to 2 groundings in 1945, the Warwick III served until March 1946. They were also flown by Squadron 167, Squadron 301, Polish, and Squadron 304, Polish. During their service, the Warwick III continued to exhibit control deficiencies, forcing Vickers to work on improving tailplane effectiveness. Several variants were tested before an auxiliary dorsal fin was designed in early 1945. This fin was retrofitted to most CMK-3 aircraft in RAF service. The Vickers Warwick began its life as a bomber designed to meet a technical specification. However, it never served as a bomber, and its production continued largely by inertia. By 1943, however, the Warwick found opportunities to prove itself in other roles, as a transport, a search and rescue aircraft, and finally as a long-range maritime reconnaissance aircraft. Of these, its role as a search and rescue machine proved the most important, giving the Warwick the chance to make a significant contribution to Royal Air Force operations. Within the RAF, responsibility for air-sea rescue was divided between Fighter Command and Coastal Command. The latter organized squadrons known as long-range search units. The Air-Sea Rescue Service was formally established as a directorate within the Air Ministry in February 1941. From that time until the end of the war, more than 10,000 people were rescued in the United Kingdom and overseas. Fighter Command was the first to systematize its search and rescue work, forming 4 mixed squadrons in September 1941 that operated Lysander aircraft and Walrus amphibians. Coastal Command initially lagged behind due to a lack of suitable aircraft, but in late 1941 and early 1942 it also organized 2 squadrons, 279 and 280, which were intended to be equipped with Lockheed Hudson III aircraft fitted with a special rescue system. In practice, Squadron 279 was unable to reach its authorized strength of 20 Hudsons in 1942, while Squadron 280 was equipped with Ansons since the Hudsons were too few to be diverted to this important but non-combat service. In 1942, while special rescue boats for aircraft were being designed and their production was established in small batches for the Hudsons of 279 Squadron, the problem of finding another suitable type of aircraft became increasingly urgent. The number of crews requiring assistance in the seas around Britain was constantly rising. A machine was needed that could be obtained in sufficient quantity to meet the assigned tasks. As replacements for the Hudson, the Wellington, and the Albemarle were considered, but in October 1942 it was decided instead to try At the beginning of 1943, a plan was drawn up to expand the rescue service, which included the creation of 4 deep search squadrons, each with 20 Warwick aircraft. These included 281 and 282 squadrons formed by Fighter Command. The Warwicks were to be equipped with specially adapted rescue boats or with 2 Lindholm sets of 10 containers each. The aircraft crew consisted of 7 men. Eventually, it was decided that 279 Squadron would continue to fly Hudsons while the other 3 would receive Warwicks. The decision to use the Warwick for rescue work at a time when the aircraft was already being phased out as a bomber was considered by many to be quite unexpected. A variant capable of carrying a rescue boat began to be designed, but development progressed slowly. The actions of the Ministry of Aircraft Production, which preferred the transport version of the Warwick, conflicted with the needs of the rescue service. In May 1943, a so-called transitional variant was approved. Starting in June, 40 Warwick aircraft that were formerly considered bombers were modified to meet the new requirements. These requirements included the Lindholm system but did not require the presence of a boat. At Vickers, these aircraft were called Warwick Bomber ASR, while in the RAF they were officially designated Warwick ASR. In the service, they were nicknamed Bomber Rejects. 2 Warwick bombers were used for experimental purposes. One was tested with the Lindholm system and the other with the boat, while the main production series was being converted. The ventral turret was removed, but all other armament remained in place. Turrets in the nose, tail, and dorsal positions, a total of 8 machine guns. Although patrols were expected to be flown in distant areas where interception by the enemy was unlikely. Trials of dropping the rescue boat were successfully carried out in July 1943. At that time, 10 Warwick rescue aircraft of Variant A were delivered, capable of carrying either a boat or the Lindholm system. With a weight of 43,200 pounds, such a Warwick had a speed of 235 miles per hour at an altitude of 4,000 feet. The boat could be dropped at speeds between 100 and 130 miles per hour. Another 20 Warwicks were built as Variant B, which had radar with antennas under the wings and in the nose of the fuselage, and an improved tail turret. Finally, the definitive Variant C appeared. This final type had all the features of Variant B, but also carried an increased fuel supply, extending its range to 2,000 miles. It also carried a modernized boat, which was first tested on a bomber set aside for experiments in October 1943. Whereas the earlier boats, for the Hudson and the Warwick, 20 feet long, were dropped with 3 parachutes. The new boat, 30 feet long, used only 2 parachutes. This new boat, capable of carrying 10 men and transporting them up to 300 miles at an average speed of 7 knots, weighed 3,600 pounds compared to 1,700 pounds for the earlier model. Because of this, the Warwick could not carry both the large boat and the Lindholm set at the same time. Variant C was the final production type of rescue Warwick, and in May 1943, additional orders were placed for it. At the same time, transport variants were also ordered. In total, 219 Warwicks were produced in the rescue version, 40 transitional type, 10 Variant A, 20 Variant B, and 149 Variant C. Production continued with aircraft from the second order, another 56 rescue aircraft. All these machines had the same engines as the original bomber, but 95 aircraft were fitted with other engines. 70 of them were from the second order and the remaining 25 from an additional order. Deliveries of rescue Warwicks to 280 Squadron began at the end of the summer of 1943. This unit, operating from Strubby and later from Langham, received mixed equipment. The delay with the transitional aircraft meant that later versions arrived in parallel with them. The aircraft went into capable hands. The stories of how they located downed crews, supplied them with rescue gear, and guided rescue launches became an integral part of the history of the rescue service. As planned, 281 and 282 squadrons also received Warwicks at the end of 1943 and the beginning of 1944, respectively. 279 Squadron continued to fly Hudsons until the end of 1944, when it received rescue Warwicks. Meanwhile, the need for a rescue service in the Middle East became clear. Following the formation of 283 Squadron in Algeria in February 1943, 284 Squadron appeared in the same theater a few months later, transferred from Britain to Malta. Both units initially operated the ubiquitous Walrus aircraft, but in July it was decided to equip each with 20 Warwicks. In March 1944, the arrival of the Bomber Rejects provided the long-awaited opportunity to strengthen the air-sea rescue service in the Mediterranean, the Adriatic, and along the coast of Northwest Africa. To extend their operational range, in September 1943, squadrons, the 283 and 284, were each divided into 2, creating squadrons 293 and 294. However, the strength of each squadron fell from 20 to 10 Warwicks due to the lack of replacements. The Warwicks that arrived in the Middle East had many teething troubles. Between August 1943 and January 1944, 61 modifications were introduced into the design, which also delayed their widespread use. Although rescue boats were rarely used in the Mediterranean, they proved very useful in the northern Adriatic, where dense minefields hindered the operations of fast boats and Catalina and Walrus amphibians. In 1 month, April 1944, a pilot from 260 South African Squadron flying Thunderbolts was rescued 3 times by boat. Twice Warwicks dropped them, and the third time an American Flying Fortress adapted to use the same British boat. Several rescue Warwicks served with 520 Squadron in Gibraltar at the end of 1945 and the beginning of 1946, where they were used alongside other types for meteorological reconnaissance. By the end of 1943, plans were made to equip 292 Squadron, which was being formed at Jessore for rescue work in the Indian Theater. It was to consist of 20 Warwicks and 10 Walruses. But, as everywhere, Warwicks arrived slowly, and when they did, from April 1944, they proved very unreliable due to rapid deterioration of the fabric covering. By that time, Lancasters were being prepared in Britain for rescue work, but none of them reached the Far East before the end of the war in Europe. The Warwicks of 292 Squadron remained in India until the end of 1945. During their last few months, they flew painted with special aluminum paint as a temporary measure to combat fabric decay. The reorganization of the rescue service in Europe during the Normandy landings led to an increase in the number of specialized coastal command squadrons. As a result, in 1944-1945, rescue Warwicks operated from bases in Britain, with 276, 277, and 278 squadrons, and with 269 squadron in the Azores. When the only Warwick of the second modification with powerful Centaurus engines was tested, it became clear that the additional power of these motors gave the aircraft significant advantages. But by the time these 18-cylinder engines with a unique valve system became available in large quantities, the need for the Warwick as a medium bomber had already disappeared. Instead, attention turned to a maritime reconnaissance version for Coastal Command. Vickers developed this project under the code name Type 469. Two versions were planned, one with a powerful Lee light searchlight for illuminating targets at night, and a bomb load of 15,240 pounds in the form of conventional or depth bombs, and another with three 18-inch or two 24-inch torpedoes, or 12,250 pounds of bombs. Initially, production was to be divided between these two variants in a ratio of 1:3. But eventually, the searchlight version was abandoned, and the torpedo bomber went into production as the Warwick Maritime Reconnaissance aircraft of the second modification. A radar was installed under the nose. The nose turret was replaced with a transparent plexiglass nose fitted with a single heavy Browning machine gun. Production of 132 such Warwicks completed the second order, which also included transport and rescue variants described earlier. The order as a whole covered 440 aircraft, but 82 of them were never built. Of the 358 produced, 100 were transports and 126 were rescue machines. The reconnaissance aircraft produced were little used, with some going to training units. 524 Squadron, which had flown Wellingtons until the end of the war, received one Warwick of this type, and was apparently to be the first to re-equip. But the end of the war in Europe interrupted these plans. Another 5 reconnaissance Warwicks were used by the Bristol Company for flight testing of later Centaurus engine versions. 14 reconnaissance aircraft were built in a slightly different configuration for meteorological reconnaissance and for crew training and high-altitude navigation. All bombing equipment was removed, an improved oxygen system was installed, and other changes were made. However, these aircraft were never actually used. The requirement for a Warwick with a Lee light for Coastal Command was revived. This modification, designated the 5th version, became the last to enter production. An initial order for 225 was later followed by another for 300 aircraft. Partial cancellation reduced these numbers to 108 and 127 respectively. Of the latter, 25 were rescue types, and the remaining 210 carried the search. The Lee light was designed as a retractable device mounted beneath the fuselage, which forced the removal of the dorsal turret. Instead, 2 heavy beam Browning machine guns were installed. The 4-gun tail turret remained, as did the nose section from the previous modification. The searchlight version, fitted with Centaurus engines of the 7th series, first flew in April 1944. During the flight trials, maximum takeoff weight was steadily increased to 51,240 pounds. As previously noted, longitudinal stability was a problem for the Warwick. At the beginning of 1945, this led to the addition of an auxiliary dorsal stabilizer, which was also fitted in service to the transport versions. This modification was accompanied by restrictions on the rudder deflection angle and changes to the size and operating mechanism of the trim tab. Just as the war ended, 179 Squadron of Coastal Command began re-equipping with the searchlight version at St. Aval. Planned re-equipment of other squadrons was cancelled due to the end of hostilities and the decision to adopt the Lancaster as the standard post-war reconnaissance bomber for Coastal Command. The Warwick's service in the RAF soon came to an end. Despite its many shortcomings, the Warwick was ultimately assessed as a useful aircraft for offensive operations, one that might have made a significant contribution to the Pacific War had it not ended. Several experimental Warwicks can be mentioned. At least the second prototype deserves note, as it was modified to test remotely controlled rear-firing turrets in engine nacelles designed for the Windsor. One transport Warwick became a flying testbed for Sabre engines of the 6th series, fitted with annular radiators. It flew until the end of the war. Another similar aircraft, a searchlight version, received a civilian designation and was used by a British airline from October 1945 to determine the operational characteristics of Centaurus engines of the 7th series. The last to operate the Warwick were the South African Air Force, 2 of whose squadrons each received 16 searchlight-equipped aircraft and returned with them to South Africa after the war ended.